Good morning. We're continuing our study of Chapter 5 with normal probability distributions, and today we're focusing on finding values. So, this section is kind of the opposite of section 5.2, where we were finding probabilities. In 5.2, we were given a value, an x value, and the question was, what's the probability that x is less than, whatever value? Or what's the probability that x is greater than some value, right? Or what's the probability that x is between some values? Those were the issues that we were studying. And we were given values and we wanted to find probabilities. In this section, we are going to be given probabilities and we want to find the values. Okay. So we'll actually have two learning objectives, not three. So let me cross out this middle one here. We really won't need to learn how to transform a z-score because our technology is going to allow us to, the TI-84 does that automatically. So the two objectives that we'll have are, number one, finding a z-score if you're given the area under the normal curve, right? So if you know the area and you want the z-score, how do you do it? The answer is going to be, instead of using normal CDF, you're going to use invNorm. So there is a command that we'll give our calculator. We'll put in the area, the cumulative area, and it'll spit out the z-score. Okay? And then we will deal with the same issue in a more generic or a more general version, how to find a specific data value of a normal distribution given the probability. So here, you know the probability, because remember, probability is the same thing as area, probability, aka area, and you want an x value. Okay, so this slide here is just kind of describing what I was talking about before. In 5.2, you were given an x value and you wanted the probability. Now, so you were given an x value and you wanted the probability. And how we did that was we used normal CDF, lower, upper, and then your mean and your standard deviation. And now we'll be given a probability and we will want to find our x value. And so the command we'll use is invNorm. Okay, let's look at the first example. Find the z-score that corresponds to a cumulative area of 0.3632. So our first step, as usual, is to draw a picture describing the situation. So you want to sketch your normal distribution. Now, because we want to find the z-score, that means we're going to label this axis z. The z-score means you're dealing with the standard normal distribution. So what is the mean? The mean is always 0. And your inflection points are going to be at 1 and -1 because the standard deviation is 1. So remember that for the normal, the standard normal distribution has mu equal to 0, sigma equal to 1. So your inflection points are at plus and minus 1, right? 1 and -1. And your center is at 0. Okay, so we've got this. We've got our layout. Now we need to shade the appropriate region. Notice here that we want the z-score that corresponds to a cumulative area of 0.3632. That means the area to the left needs to be 0.3632, right? So I'm just going to kind of shade in this area here just as a guess. And the idea is that this area, this cumulative area, is supposed to equal 0.3632. Now, I've got the picture, and what I want to know is, I want to know what is the z-score that gives me area, a cumulative area of 0.3632. And now here is the syntax. So on your TI-84, go to second vars for distribution. So let me get ready to write this down. Okay, so we want second, we want vars, and on top will be DISTR for distribution. So you click that. Now go to inverse norm. So number 3, which is going to be inverse norm. Okay, because what we're doing is we need the inverse of the normal CDF. So click number 3. You'll get a menu. The menu says area, mu, sigma, paste. So this area refers to the cumulative area. So we're going to plug in 0.3632. Plug in 0.3632. For the mean, what is the mean? The mean is 0. The standard deviation is 1. Click paste. Click enter. Up will pop inverse norm. Now why does this happen? This happens because the calculator is giving you one last opportunity to verify that you've entered in exactly what you want to compute. Now if you have, this is for the newer TI-84s. If you have a very old TI-84, then when you click 3 inverse norm, you won't get this menu. Instead, you'll just have to punch in these numbers or press these numbers right here. Right, so you'll just have to press in 0.3632 and then comma 0 and then comma 1. So the syntax is inverse norm, and then here you want to put your cumulative area, and then you want to put your mean, and then you want to put your standard deviation. Okay. Okay, so now hit enter again, and what we get is, the number I got is negative 0.349918. Oh, sorry. So I got negative 0.349918. So what that means is that this z-score is negative 0.3499. So essentially negative 0.35. So the z-score that corresponds to the cumulative area of 0.3632 is z equals negative 0.3499. That's my final answer. So do you see how we're given an area?
It's 9 hours.
And we want a z-score. And the way we do it, the command that we use is inverse norm. Let's do another example. Finding the z-score that has 10.75% of the distribution's area to its right. First thing we want to do is draw a picture of our situation, a graph of our normal curve. Okay, now label the horizontal axis Z. Why do we label it Z? Because we know that we want a z-score, and since z-score means we're working with the standard normal distribution, the mean is going to be 0, the center is going to be 0, and the inflection points are going to be 1 and negative 1. 1 and negative 1. Okay, so what are we given? We are given 10.75% of area to the right. And what do we want? We want a z-score. So now, 10.75% of the area is to the right. What is the area? What is the entire area of the distribution, or the area underneath the normal curve? The entire area is 1. So 10.75% of 1 is going to be 10.75% of 1 is just going to be 0.1075. So we want an area that is, so I'm just going to shade this a little bit here. And essentially that area equals 0.1075. Now, why did I shade it to the right instead of to the left? Because it says here to its right. And the question mark, what we want, this is what we want. We want to know what is the z-score that has this area to the right equal to 0.1075. Now, in order to use our calculator, remember we need inverse norm of the cumulative area. Cumulative area, comma, the mean, comma, the standard deviation. The cumulative area is always the area to the left. So the cumulative area is going to be 1 minus 0.1075. So I'm going to go into my calculator, and where it says area, mu, sigma, and paste, for area, so let's see here, second, vars, go to inverse norm. Now for area, I'm going to put in 1 minus 0.175. So just plug in 1 minus 0.1075. And then for area, for mu, 0. For sigma, 1. So do you see what we're doing here? So this is the window. Okay. And then click paste. Hit enter again. And I get 0.9345892869. Okay, so I could round this off and say that this cumulative, that my z-score that I'm looking for is 0.93. Okay, so that's my z-score. So let me actually, to summarize, let's add a page below. So to summarize, our sketch, and remember you should be sketching with every single problem that you do, because I'm going to be looking for sketches on the exams and looking for sketches on your written homework. And the sketch needs to have the axis label, the horizontal axis, the center, and the inflection points need to be labeled. Okay, and now at the point, so this area right here, area equals 0.1075, and then over here the area to the right is the cumulative area, so we can say the cumulative area is going to equal 1 minus 0.1075. That's this area here, right? So all of this is 1 minus 0.175. Now how did I get that for the cumulative area? I got it because the total area has to equal 1. So the total area has to equal 1. And that's going to be the area to the left plus the area to the right. I'm running out of room here. Plus the area to the right. Okay, so the cumulative area is the area to the left. So if I know the area to the right is 0.1075, then the cumulative area has to be 1 minus 0.1075. And so into the calculator, inverse norm, my cumulative area, 1 minus 0.1075, comma, my mean, 0, comma, my standard deviation, and I get 0.934589, dot, dot, dot. So this z-score must be, I can put my little z-score in, this is approximately 0.93458. Can you tell that I've drawn my picture incorrectly? Because if my inflection point is 1, right, and 1 is here, 0.93458 should be to the left. So I need to adjust my picture. So 10%, right, 10% is actually a little bit, I'm going to just move this over a little bit, right, and I'm going to just say, oh, this is 0.93. Okay, so this is actually a more accurate picture of the problem that we're working with, right? So what is that z-score? That z-score should actually be to the right. So let's go ahead and correct that. And then move the 0.93 over. Okay. And then now all of this area here. Okay, good, good, good. Okay. Now we're going to make a slight difference. Here's the difference. We're introducing this new notation. Remember the percentile, right? If you're in the 5th percentile, P5 means you're in the 5th percentile, which means this is the value that is larger than 5% of the data. So we're going to sketch our z distribution. So label it with z, 0, 1, -1. And now I need the number, what number is larger than 5% of the data. So now 5% of 1, what is the area going to be? The area is going to be 5% of 1 because the area, this is the total area, right? So 5% of 1 is just going to be 0.05. So I need this area to be equal to 0.05. I'm lucky because this area is exactly the same as my cumulative area. So I'm going to put in inverse norm. For my cumulative area, it'll be 0.05. For my mean, it'll be 0. For my standard deviation, it'll be 1. And I get, so second vars inverse norm. For my area, 0.05. For my mean, 0.1. Okay, paste. Negative 1.64485. Okay, all right. Good to know. So let's zoom in. And this should be negative 1.645. So now, do you remember that if you have an event that occurs less than 5% of the time, that event is considered unusual? So here, negative 1.645 is the kind of the determining factor, or that's the borderline, because if your z-score is less than that, then that means that that event occurs less than 5% of the time. That is an unusual event. Okay. Now, transforming a z-score to an x-score, we are going to skip this, and I think I have deleted these, or I should have deleted this in what I posted, because transforming a z-score to an x-score and finding an x value is important if only if you don't have technology. So if you're using tables and charts, like in the olden days, then you would need to, focus on learning this formula. But for us, our technology does those computations for us. So let's look at this example here. Scores for the CPOST, California Peace Officer Standards and Training, right, CPOST, right, which is a test, are normally distributed. So the scores are normally distributed with a mean of 50 and a standard deviation of 10. So let's say X equals scores on the CPOST. And now we are being told that the scores are normally distributed, so we can go ahead and draw a normal distribution. Now label the horizontal axis X. The mean is 50 with a mean of 50 and a standard deviation of 10. So if the mean is 50, that means that my center is 50. And if the standard deviation is 10, what are my inflection points? I'm going to have 2 inflection points. And the inflection points are going to be, remember my inflection points are mu plus sigma and mu minus sigma. So mu plus sigma is going to be 50 plus 10, mu minus sigma 50 minus 10, right? Because the mean is 50, that means mu equals 50, and we've got a standard deviation of 10, so that means that sigma is equal to 10. All right, so we'll have 60 here and 40, so my inflection points are 40 and 60. Okay. So an agency will only hire applicants with scores in the top 10%. Ooh, okay, so you got to be in the top 10%. What does that mean? If you're in the top 10%, that means that you are in the 90th percentile, right? This area is going to be 0.10, and the cumulative area is going to be 0.90. Because remember, when we add up the area plus the cumulative area, the sum should be 1. So our goal is to figure out what is the score that will give you, what's that borderline score that will lead you, right, so that you are scoring better than 90% of the people. So for our syntax is going to be inverse norm. And now, what is our cumulative area? 0.90, or you can just put 1 minus 0.1. What is our mean? 50. What is our standard deviation?
It's
10.
9:15.
And what do we get? So let's see here. Second, vars, inverse norm. My area is 1 minus 0.10. My mean is 50. Standard deviation is 10. Paste, enter. So I got 62.8155. So this score, 62.8155. So what this means is, what is the lowest, here's how I interpret this. What is the lowest score you can earn and still be eligible to be hired by the agency? 62.8155 is the lowest. Okay, so the lowest score, 62.8155, and still be hired by the agency. There we go. So in summary, What I'll say is number one, we don't have to transform the z-scores. The reason why we don't is because when you have your inverse norm, right, when you have inverse norm, you've got your area, your cumulative area, you've got your mean, and your standard deviation. Because we're able to put in different means and standard deviations, we don't have to transform a z-score to an x value. Okay? When we're finding a z-score given the area, right under the normal curve, the first thing we have to do is make sure that you convert your area to your cumulative area, right? Find the cumulative area. That's number one. And then number two is use inverse norm with mu equal to 0 and sigma equal to 1 because you're finding a z-score, so you are working with the standard normal distribution. Now, for just any scenario, find a specific data value given the probability. Here's what you want to do. Number one, turn the probability into an area. So probability, convert that to area, and then convert the area to a cumulative area. And then number two, use inverse norm with mu, whatever mu you're given and whatever sigma you're given. Okay? All right. That's it. Thank you.